Assalamualaikum and good day, student. Welcome back to my FOC classes. We will discuss a bit today regarding the belt drive concerning the centrifugal effect. Let's revise first on the previous lecture. Like say there is a belt system, pulley R1 and pulley with a radius 2 with a tight side tension and then a slack side. So you know that the moment torque occur at the pulley 1 is equal to the resultant tension of the belt times the radius of R1, while the power of belt at pulley 1 is equal to torque resultant torque times the velocity of the belt. This is the equation 1, while this is equation 2 for the ratio of tension. Rearranging the formula 1 and 2, you will get a bit complicated equation representing the power of belt. This one mainly is for flat belt. When considering the V belt, you need to consider the groove angle. Okay, what about the belt considering its centrifugal effect? If, like say, this is the belt running through the pulley groove, attached to the pulley groove, and then the belt have its own density with a certain unit, and then with a cross-sectional area A, and then belts also have been recognized having the belt mass per unit length. It's either given in density or belt mass per unit length. So at a certain point, when the belt is running through at a higher speed, so the belt tend to move outward because they have a centrifugal effect acting perpendicular. Acting outwards of the pulley, while the centripetals is acting radials inwards, so the belt tend to move outward. In another way of representing this centrifugal force, you can see that if, like say, this is the center of rotation, and then this is the mass, and then this is the curve of rotation. So this is the mass m, radius, this is the tangential velocity. Of course, they will create the centrifugal force outward of the radius, while centripetal is moving to the center of rotation. So basically, the centrifugal force is mr omega squared and equal to this one. What is centrifugal tension? Taking into consideration, I'm taking out this part of the belt and put it over here. Let's say this is part of the mass at the belt system. So when it moves around the pulley, it will create the centrifugal force outwards. So derivation of the formula will give the centrifugal tension at both sides of the belt. So in that case, the TT, the tension of the tight side have to add the tension, the centrifugal tension that has been created by the density of the belt or the mass of the belt, while at the tension of the slack side also need to add TC. So meaning that the tension at the tight side will become higher compared to the previous one. So the centrifugal tension Tc is known as rho AV squared or m dot V squared, where this is the density, this is the cross-sectional area of the belt. So therefore, this one has become T1 and this one has become T2, where T1 is equal to Tt plus Tc and T2 is equal to Ts plus Tc. What about the belt tension ratio? So on the flat belt, we need to consider the centrifugal tension. So the equation has become like this, considering the centrifugal tension. while the V belt, we need to consider the groove angle of the pulley itself. Okay, what about the belt transmitted, the power transmitted by the belt? This is from the previous formula, the power that could be transmitted by the belt. But when we considering the centrifugal force effect, so we need to consider the TC, the centrifugal tension. So this is the power that could be transmitted by the belt. But this one is a flat belt. Let's see what is the maximum power that could be transmitted due to centrifugal effect. Let's see the graph first. The red color representing only one belt. The blue color representing two belts in a system. You can see that the power produced by one belt compared to two belt is a bit higher. But we need to discuss about the belt speed. There is a critical belt speed that need to be discussed here, since when it's already come into peaks and reach the critical speed of the belt, you can see that the power will decreasing. The power produced by the belt will decreasing because of the pulley and belt is slip. Too much speed of the pulley will create slippages between pulley and belt. So at this point, at the peak point, we know that dP over dV is equal to 0. So from the derivation of this equation, we notice that T1 is equal to 3 times of TC, 3 times of centrifugal tension, where we can actually derive the critical speed of the belt, knowing the density and cross-sectional area of the belt, also the maximum tension allowable in the belt system. Let's see how to derive this equation, T1 equal to 3 TC. This is from the previous equation of the power, and then this one is considering the centrifugal effect. We replacing the centrifugal effect with a rho AB squared, knowing the density and cross-sectional area of the belt, and then the velocity of the belt. You times the V, you will get the new equation. The new equation times the V over here, we get the new equation. And then let's consider this one as C only to simplify the equation. Okay, now we expand the equation to become something like this. If you notice that at this point dP over dV is equal to 0, so dP over dV, deviation of this one is T1 C 3 rho AB squared C. So this one is actually equal to 0. So what we get here is something like this. So it's proof that this equation, you already derived the equation. Okay, what about the critical bed speed? From the previous equation, just now you do, this is actually the T1 3 rho AB squared. So we just simplify the equation until we get the critical belt speed equation. So we're just replacing rho A is actually representing the m dot. M dot is the kilogram per meter. kilogram per meter. Okay, this is the critical speed of belt. Okay, we have one exercise that you need to answer and submit to me via the link provided. Okay, you may go through the link first and then submit to me. Okay, thank you very much and take care of your health. Thank you.